Hello there. A while ago, I posted a video explaining how to write a text adventure in BASIC, in Applesoft BASIC. And I got some really nice comments. I have a comment here from a viewer called SD, and I suggesting that perhaps I could consider making a version with graphics, text adventure with graphics in BASIC, Apple II style. Um, and the viewer mentions that they have a bucket list of replaying cool text adventures that yeah they enjoyed while young, but never got to complete. I actually have that bucket list as well. I have downloaded in these emulators, and even I have some on the actual Apple IIe over there. Some of these games like Transylvania or Swiss Family Robinson or Amazon, and they are actually surprisingly challenging. I am struggling to finish many of them, but of course I don't want to search for hints online because yeah, that kind of defeats the purpose. But anyway, I thought it was a very interesting challenge to uh, modify our simple get lamp text adventure to now have graphics. So in this video, we're going to briefly examine an example of a text adventure with graphics from the 80s, the Transylvania, and then I will proceed to show how we can change our existing uh, text adventure. This is our GetLamp text adventure to have graphics. And I will not type the whole code like I have done in prior videos, because I think you already get the hang of that. And if you don't, please check my previous video on how to get the initial text adventure set up. I will, of course, put a link to that. And but we're gonna expand that one with graphical subroutines in the Apple IIe, and we're gonna examine in detail what these different subroutines are doing. And it's going to be fun, certainly for me, and I hope for you too. So thanks, SD, for this very nice suggestion, and I hope you enjoy this example of a text adventure with graphics from the Apple II that I really liked. Was Transylvania by Antonio Antioquia, and yeah, this is the opening screen. And the interesting thing is that you can see is that the graphics, they are drawn, right? You see that they don't come as a complete bitmap, but every different part is drawn, and this is really being drawn by the CPU. And this is sort of the effect that we want to achieve. Yeah, that would be a good representative of the kinds of graphics that we had in this classic text adventure. So you see the object in this case, this wrinkled note, is it's the latest to be. It's the last one to be drawn, right? It's like the topmost layer of the picture. So if I take this note, it just re-renders the screen, but now without the note. And now if I were, for instance, to drop the note, you see it's basically drawn the same place. So we can clearly see that there is a routine that draws this note. And depending on whether the note is on this location or not, it is drawn, and it's the last thing to be drawn. So by drawing the things in the right order, drawing the background and some foreground elements, and then objects or monsters would be the last to be to be drawn. Okay, that's a real example from an actual game, and this is sort of the standard. Yeah, I don't mean necessarily that level of good art, because yeah, honestly, I'm not an artist. I can't do this level of detail, but the idea that you have this kind of graphic is the thing we're shooting for here. Okay, so one of the first things you need, of course, if you want to have graphics, you need to know how to draw in BASIC. The Apple II has two graphics modes. The high resolution graphics, which is the one that we want, and that will give you a window of 280 by 160 pixels, and also gives you 4 lines of text underneath the graphics. There are other graphic modes that you have full screen graphics, which we don't care because we want to have the still the interaction with the text. And there is a low resolution graphics mode that it's also not very interesting for us. So in order to enter into high resolution graphics mode with the 4 rows of text, all you have to do is type HGR, as in high resolution graphics, and there you go. This emulator is emulating a color display, so we can change the color. For instance, you can assign values from 0, which is black, through 7, so 8 values in total. You're very limited in colors. Let's choose 3, which is a white color. And now you can basically plot on the screen using this color. You can plot dots. For instance, you could say hplot. This is high resolution plot, point 50, 110, and there you go. You got a point. So in modern computer graphics, usually images, they are stored in bitmap format, meaning that for each pixel that you have, in our case, it's 280 by 160 pixels, you can have one out of 8 possibilities of color. So you would require 1 byte per pixel. And if you had a file of 280 times 160 bytes, then you can represent one image. The problem is that consumes too much memory for these old computers. And I mean, typically in an image, you're going to have large areas that are just painted with a solid color. So you're repeating the same information for every single byte in that area. So it's not a very compact way of storing your images. So what most adventures, text adventures with graphics would do on the Apple is they would not use any bitmap, but they really would have drawing instructions to draw your graphics. For instance, in our little text adventure, most of the action happens inside rooms, right? Office rooms, the stock room, dark room, etc. So we could get a basic layout of a room if we draw a line between uh, this point and let's say this one, and then we draw a diagonal from this point through this corner, and then we draw yet another diagonal from the other corner to the extreme of our, oops, that's not what I meant. Let me do that again. So what I meant was from 230, 110 to 279,160. Forgot to type that little 2 over there. So ignore this mistaken line, but you can see how we have already a bit of the shape of a room starting to come together. Let me retype this. And if we keep doing it like this, we can draw a room, we can draw objects. Of course, it's all very crude, but that's kind of the point anyway. So this is a brief explanation how we would go about it. In the next section, I'm going to walk you through a bit of longer code segments where we incorporate this into our existing code for the text adventure. Okay, so in this particular case, I will not type the whole program with you. You can find the link, the comments of this video, the link taking you to the full code, but we're gonna examine at least parts of it together. So it's essentially the same program we had as before, the same text adventure. There are very few changes to the existing code listings, and on top of that, we have a number of new subroutines that we have added. So one good example that we can see here is a subroutine that just draws the outline of a room. So in this case, this subroutine is in lines 1940 through 1945. There you see it. Let me get some light. Yes, that's better. So you see it, we're actually missing, I think, one line here, 1945. Yeah, no, that's correct. So this routine basically is setting the color to 3, which is whitish, and then drawing a number of lines. And we already had an idea, so if you want to see what this does, so we can come and execute directly line 1940. Yeah, and that because this subroutine returns at some point, and we are just running this line, we get this error, but we don't care. You can see the result of this particular subroutine, and that's what matters. And if we take a look, for instance, lines 1950 through 1957, no, 59. This is drawing a desk, and the desk is again a bunch of lines. The color here is 5, which is orange, but it's the closest thing we have to brown, a wood color. We have a bunch of lines, but then on line 1957 and 1958 we have something different, and that's a call to subroutine that draws a circle. I actually took this subroutine from the internet. Someone posted some very interesting subroutines for drawing circles and to solving other interesting problems in BASIC. I will put a link to where I got this code. But basically, this subroutine, you set 3 variables. That's center x, center y, and the radius, which is r, and then we draw a circle. And in this case, this is meant to be the knob of the drawer of the desk. So let me show you. So run 1950. Yeah, so there we have a desk. And then if we take lines 1960 through 1969. So again, we're just drawing a shelf. Yeah, there it is. So we have the room, right? And then we have these furniture elements that allow us to differentiate different rooms that we have, putting elements there. And then we also want to draw some objects. So for drawing a lamp, I do that in lines 1970 through 1989. So the lamp, you see that it starts with a circle, and then we have a bunch of straight lines here. It's just drawing a box of sorts around the circle, and that I hope looks like a lamp. So let's take a look around 1970. Okay, that's actually pretty good in my unbiased opinion. And finally, we have another object that's a key. Oh, sorry. So this is in lines 1990 through 1999. That's a small subroutine. So we again draw a circle, small circle, and then we draw two very short lines, which are the kind of the teeth of the key. Yeah, they probably have a better name, but I don't know what that name is. So that 1990, yeah, you see, it hopefully looks like a key. And the draw circle subroutine, which we have used a number of times already. It starts on line 2200. I don't think we can see the whole thing in one screen, so I'll put 2285. But yeah, this is the routine that I have taken, and it's yeah, basically using square roots to figure out to calculate what are the dots around a certain XY coordinate, and then draws it. And okay, so you can see that we have here all these subroutines that draw objects. I also had an interesting one which is meant to draw the world outside. It's the last screen that you have in the game. Oh, this is wrong. So it starts 1920 and ends on 1929. So this one is also a bit different from the others because it fills rectangles with colors. So here we have some for statements, and what these for statements will do is that for every line, right, every row that we have on the screen, and that's the y coordinate from 1 to 110, we are going to plot a line from the start of the screen through the end of the screen. Just keep repeating this, and we use the color blue, and then we do that with color 1 from row 111 to 159, and then basically we have two big rectangles, one blue, one green, and hopefully that looks like the the grass and the blue sky outside. And then we have another 4 here from 1 to 9, where we are drawing concentric circles in color white. We don't have yellow, and that's meant, of course, to be the sun. It looks cool. Later we're gonna see a walkthrough, and you're gonna see that this looks actually quite cool. And those are the things that I have added to the game, mostly. So now let's see what we have changed. So first thing, because we are limited to 4 text rows at the bottom of the screen, we cannot have long text. So every time you interact with a command, let's say you do an inventory, or you do a take item, drop item, help, all these things, I introduced a small subroutine that gets called that basically asks the user to hit enter, to hit return in Apple II lingo. Every time you have seen your text, and then it will recycle the screen and repaint everything and show the description again. And I hopefully you get what I mean. It's very clear when we run the game, and I have put this subroutine, I think, around this part. Yes. So it's going. This inverse makes the foreground of the text to be white and the background to be dark. So that's one change that and I call this subroutine pretty much after each command. And the main loop of the game, of course, now has to draw stuff. So let me show you what happens now in lines 100 through 130, 120, it's fine. So what we do now is you in the main loop you do an HGR command. Basically, we are wiping the screen. We are setting high resolution graphics mode, but we are getting the screen empty. So we get rid of what was painted before. Then we paint. I'm sorry. We print. You are in a room. Blah blah blah. And then we already had this display objects, but I added lines 112 and 117 where you call subroutines that draw the room, whatever the room it is, and where we draw the objects, because we call this later, they will be in front of the scene. So let's see what these subroutines look like. The one that draws the location, it's sitting in lines 1900 through 1929, I think. No, oops. No, 1900 through 1919. Yeah, that's better. So, and this is a bit sloppy. Of course, if you have many rooms, you need a better strategy than this, but for our case, this is good enough. So what happens is you got here, if your location is 1 or 2, then you go to line 1930, which is basically draw the room, the empty room. If we are I'm sorry, I'm confused with my own code. I'm sorry. So if location is 4, right? Because we have 1, 2, 3, and 4, rooms 1, 2, 3, and 4. Location is 4. Then we basically return. This 1930 is a return statement. It's going to get back. If it is 1, 2, or 3, then well, actually, if it's 1 or 2, then we go directly to draw the room. And let's say it's room 1. So room 1 is the office, then we draw the desk. If room is 2, that means is the stock room, we draw the shelves and then we return. And if here actually it was not 4 and it was also not 1 and 2, that means if it got to line 1912, we are in room 3, and room 3 is the dark room. So if the object description of the lamp is still a lamp as opposed to a lit lamp, then it will return, right? Go to 1999, that's return. It's going to return. We're not going to draw anything. You're going to have an empty dark screen, which is what you want because this is a dark room. But if the description is a lit lamp, right, you have lit the lamp at some point, then yeah, this is not happening. We are going to draw a room, just draw a room, but not draw any furniture, which is fine because it's an empty room after you can look at it, inspect it with the lamp. So this is what a draw location subroutine looks like. There are little changes here and there. I've made the descriptions of the rooms slightly more compact, so it's not exceeding those 4 lines of text. And I have also added uh, at the very beginning of the game, just a for loop. That's line 96. I can show you. It's a for loop that just skips a number of lines, and the goal is to do something like this. It's to put the cursor at the bottom part. So when you have the HDR, you can actually see the text, right? You are not in a situation like this, for instance, where you can see anything because the cursor is kind of hidden behind the graphics part. But if you keep hitting return, eventually you see it. So this is what this for does. And that's pretty much it. There may be small details that I forgot to mention, but it's easy if you compare. I have added to the source code the separate code of the original pure text version with now this version that you um, have graphics, and you can easily compare. You can see the difference. And now all that is left for us is to actually go for a tour and play it. Okay, let's take it for a spin then. Okay, that's a nice start. You are in an empty office and there is a door south and the locked door east. I have not shown the doors. I was lazy. Of course, ideally you would do that. It's just add routines to paint the doors properly. But what we can do here is get this lamp. You see, this is what I meant. You have, after the result of the command, you are asked to press return. And the goal here is that we can read the message. In this case, a successful message that we have picked up the lamp. Yeah, and then the main loop is called again. We redraw the screen, and now because the lamp is not here, then we don't see it there. There is a subroutine for displaying the objects. It basically checks if the objects are, each one of them are in location L, which is the current location, and if they are, we draw it. If they aren't, we don't. So yeah, right now I have in my inventory the lamp. So the inventory is, as you might recall, it's has the value 0. So it's not the value of any of the location, so it's not here. So let's go south. Okay, so here's the stock room, and we see a key. We know by now we need this key, and we can go back north. And if we try to go east, oh no, locked door. So let's open door. Okay, here's the dark room. So that's a good moment to light a lamp. Hey, now it's empty, but at least I can see it. And now if I just go south, these animations, they kind of take a long time because the CPU is rendering it, but it's actually part of the fun. It adds to the character, I think, that we have this rendering. So yeah, this, you see, it's a different style of art than the others. Of course, you can achieve something like this by painting rectangles and triangles, and I'm pretty sure you can find examples of routines to draw triangles. If you have combinations of triangles and rectangles, you can paint shapes that are irregular. And for instance, like the slope of the walls in perspective, and you could paint the walls or part of them. It's just probably poor if you paint everything, because yeah, it takes a long time to render. In the last screen, the one that's the victory screen, it's fine that we get something that's a bit different, I think. But yeah, you have to basically, you have to weigh out these different possibilities. But yeah, that's the end of the tour. And this now we have a version of the Get Lamp game, not only with text but with graphics. And I hope you enjoyed it. I certainly enjoyed making this example. Okay, thank you, and so long.